Okay, so classic rock radio station claims to play an average of 50 minutes of music every hour. To investigate the station's claim, you randomly select 12 different hours during the next week and record what the radio station plays in each of the 12 hours. Here is how much music in minutes was played during each of those. So the sample is 12 different hours. So, like, for example, in the first hour, 48 minutes of music was played out of 60. Second hour, 49 minutes of music was played out of 60. Okay. 50 was the next one, 51, and so on and so forth. All right. So we have to, does the evidence give convincing reason to question the radio's claim? Okay. Convincing reason, evidence, that means a test, right? That means a test. So before we do the test, though, let's see what we have. Looks like we have a sample of 12. We don't have a population standard deviation, so it's going to be a t test. It says a claim. The station claims an average of 50 minutes of music. So that looks like that's their claim, 50 minutes of music. So when we get to hypothesis, that's what our claim is going to be. Okay. Okay, so now that we got that, let's start our test. So it's mean. So the true mean, let's see, amount of music or minutes of music played. True mean minutes of music played every hour by this radio station. Okay. All right. Next one is hypothesis. Hypotheses, both hypotheses. So we have the claim and what the alternative is. Okay. Well, the claim was 50 minutes. So we're going to put equals 50. So judging by the question, judging by the data, judging by everything we have, we know this is going to be 50. Our question is which symbol? Greater than, less than, not equal to. Which one would you think it would be for this one? It's, yeah, the claim is 50 minutes, right? It doesn't say anything about we think it's more or we think it's less, or it doesn't say to test the radio's claim because there's nothing like it, right? So it's just different. It's just different. In reality, if a radio station plays more music, that's a good thing, right? More music means less commercials. That's what people don't like. But for this one, I would say not equal to. Okay. Significance level or alpha level. Doesn't give us one. So we'll just use, but I see part B has something about a 5% significance level. Part B does. So gives me more reason to choose 0.05. I don't know what it involves, but I know that it's talking about 5% significance level. So it's good that we picked 5%. Okay. Test statistic or formula that we're going to use for this test. Well, this is a t-test. So if it's a t-test, we're going to use the same one we used yesterday. On top, we subtract x bar minus the true mean, or the claim, right? This is the claim, over the standard deviation divided by the square root of it. Okay. Okay. All right, so now we got to do our conditions assumptions, just like we always do. So conditions, check. First one is SRS. Let's see, how were the 20 hours chosen? It says randomly selects 20 hours. So stated. 10% condition. Okay, so little n is less than or equal to 10% times big N. Little n is 12. So little n was the 12 randomly selected hours chosen. What would big N be? All hours, yeah. All hours. All 24 every day. Okay. 3 is check to shape. Is shape approximately normal? Okay, so remember, for means, we have different, it's not n times p like it is for proportions. Number 3 is one of these 3 options here from your notes earlier. Either they said it's given, they said the population is also normal, like we did with the IQs. No, that one's not right, but our sample size is big enough. No, this one's not big enough. Our sample size is only 12 for this one, so we can't use number 2. So we're going to have to check a graph. We're going to have to do a graph. Okay, so we're going to have to put the data in L1 and graph the data. And check for outliers, check for skewness, do all that stuff. Okay? Okay, so I'm going to put up the calculator. To check skewness, you can use any graph you want. But to check for outliers, I would use a modified box plot, because that one will automatically tell you. It doesn't look like there's any outliers because the numbers are all pretty much very close together. But, you know, it doesn't hurt to check. So we're going to put the numbers in L1. $48, $49, $50. $50, $46, $48, and that's the last one. Okay. All right, for the graphs, we're going to go second, y equals. Okay. Make sure it says on. Make sure it's blinking on, the first one, because that means it'll show you the graph. If it's on off, that means it won't show you the graph. Again, any of them, But this guy right here is the guy that will tell us about outliers. And it'll give us shape too. Okay. Everything else we're going to leave. So we're going to go to Zoom, stat number 9. We're going to draw a little picture of that guy. No, the shape, we don't know if the shape is normal or not. We're just checking for outliers. There are no outliers. Okay, so we can say no outliers present. If you're not sure about shape, because box plots are the hardest ones to check shape, do another graph. We have other graphs we can do. We can go and check, probably histogram is probably the easiest graph to check to see if there's any type of skewness. Zoom stat again. It's a little heavy on the low side, not so much on the high side, but there's not any crazy skewness where it's just everything's on one side, right? So we drew a picture of the box plot. We said no outliers present and no strong skewness. Since sample equals 12. Since the sample is so little, we needed to do that. If the sample was bigger than 30, we wouldn't need to do any of this. We could just assume that it's normal. Okay. All right, so 1, 2, 3, 4, 5. Now calculations. Okay, so we need to draw a picture for tests. The claim was 50. But we don't have a standard deviation or a sample mean yet. So that's something we need to get from our calculator. We know that the data is already in L1. So if we just go stat calc 1 var stats, we'll get the sample mean here. So the sample mean was 48.917. And the standard deviation was 1.929. Okay, so those are the numbers we're going to use in our calculations. So the average of the 12 hours was 48.917 minutes. That number varied by about 2 minutes. Okay, so 48.917 and then 1.2 divided by the square root of 12. Okay, so however you want to get those calculations, if you want to use the calculator to do it, to using the test function, go to stat, tests, t-test, just like we did yesterday. Data means you have the data in L1 or L2 somewhere stored. Stats means I don't have each of the data, each of the numbers, but I know what the mean was and I know what the standard deviation were. So we could use either of them for this guy. Since we already have the data in our L1 and L2, or sorry, in L1, let's just use it there. So the claim was 50. I have my list in L1. Frequency, we chose not equal to, right? That's the one we chose. You can choose draw or you can choose calculate. Either one will give you the data we need. Okay, so I get negative 1.9458 for my t-score. And then I get a p-value of 0.0777. Okay, notice how it's shaded on both sides because it's a two-tailed test. So on our picture, we have to shade it on both sides. Negative 1 point, yeah. Negative 1.9458. That's our t-score. Okay. So going back, we need to label some of our, it's lagging a little bit. We need to label some of our, why is it lagging this bad? Let's see. Come on. There we go. Okay, so our sample mean was 48.917. That's below the mean. So that's why I put that there. But we have to figure out, since it's a two-tailed test, we have to label both sides. So we need to figure out. So to figure out that number, we have to figure out how far is this the sample mean from the mean. 1 point something. Whatever the distance is here, we would need to add that same distance to 50, and you'd get that number there. So it's going to be 51 point something. 51.083. Okay. So the calculator told me the p-value already. Each of those has already been added. So if you want to figure out what half of it is, you just divide it by 2. So take 0.077 and divide it by 2. So 0.3 something. Because when we figure it on the calculator, it already adds it for us. So each of these would be 0.0389. Yeah. Thereabouts. Okay. All right. Last thing, conclusion. since p-value is greater than alpha level, which was only 5%, we fail to reject because p-value was too big. If p-value is too big, then we always fail to reject the null hypothesis. Wasn't that much bigger. Very close, but still it's bigger. Okay. Therefore, we lack sufficient or enough evidence to suggest, and then here we have to put the alternative in words. We have to put this in words to suggest that the true mean is not 50. The true mean minutes of music played every hour. That's what this represents, is not 50. Minutes of music played every hour differs or is not from 50 minutes. Oops. Done. Okay. We had greater than, which means we fail to reject, which means we lack evidence. And then this is in context. The null or the alternative hypothesis in context. Okay. So we're not done with the problem yet because it had several sections to it. Okay, so let's go back. Question B. A 95% confidence interval for the mean playtime in minutes of all hours is right there, 47.691 to 50.142. Based on this interval, does this support or not support your conclusion? Or our conclusion was that we could not refute this claim. Right? So go back to chapter 8. When we had an interval, right? When we had an interval. And you had a question. You had questions on homework. You had a question on the test for chapter 8. And it gave you an interval and it said, is it plausible? So is 50 minutes plausible according to this interval? Yeah, it is, right? 50 minutes is plausible because why? Is 50 minutes of music played plausible according to that interval? Yes, because it's within the interval. If it wasn't within the interval, we could say no, it's not plausible. Saying something is not plausible is another way of rejecting a claim. So because 50 is inside this interval, we can't reject the claim. In other words, we fail to reject, right? We fail to reject. So what this question is saying is, well, we'd get the same conclusion if you did it using a confidence interval. Yeah, we'd get the same conclusion. Because 50 is within the interval, it is plausible that 50 minutes is the true mean. I can't reject the claim. I can't reject the claim based on that interval. Okay? If it's plausible, that means I fail to reject. I fail to reject. Okay? So let me write this down. Part B. The interval would give the same conclusion because a true mean of 50 minutes of music played is plausible because it falls within the interval. If it falls within the interval, it is plausible it could happen. If it's plausible it could happen, I can't call them liars. I can't say I reject that claim. In other words, I fail to reject. This is another way of saying I fail to reject. If you fail to reject, then it is plausible, right? If 50 wasn't in the interval, then what I could do is I could reject the claim. That's how you reject claims. So we could have rejected claims in chapter 8 if it's not within the interval. This is the best way to do it, by doing a test. If you want to reject a claim, doing a test is the best way. But you can reject or fail to reject using an interval. Okay? And then part C. Can we generalize our conclusion for this radio station for the whole year? Explain your answers. So what we found was we failed to reject, right? We failed to reject that claim. Can I use that for the entire year based on the data that I have, the sample that I have? Well, does it say when the 12 hours were chosen? Does it say they were only chosen in May, or they were only chosen in December, or they were only chosen in August? Does it say when the 12 were chosen? During the 1 week, right? They were only chosen during 1 week. So my conclusion would only be good for that week. My conclusion would only be good for that week. I couldn't say it about the rest of the year because every single sample, every single one of the 12 was picked from one single week. It wasn't picked from throughout the year.
So when we write it, we could also fail to reject.
No, we would just say, can we generalize it? No. We can only generalize our conclusion for the week in which the 12 hours were picked. We can only generalize our conclusion to the week the 12 hours were randomly selected. It didn't say throughout the year we randomly chose 12. If it said throughout the year we randomly chose 12, then yeah, you could generalize it to the whole year. It only said 1 week, so we can only generalize for that 1 week. If we want to be able to generalize it for a year, then we would have to pick 12 throughout the year. Okay.
For the 10% condition, do we still So put all hours or
Yeah, all hours.
time?
Yeah, it's a fine. Okay. All right, so here I didn't put one. It's a question. If you have some room or scratch paper or somewhere you can do this problem, I want you to do this from beginning to end on your own, and then we'll talk about it. We will talk about it in a little bit. I'll let you guys do one on your own. We did two together. I'm gonna let you guys do this one on your own. The numbers are kind of hard to see. Let me write down the numbers. Okay. There are 15 randomly chosen locations. Or so at each of the 15 locations, they got they recorded the level of dissolved oxygen in the water or the stream. So at each of those locations, they got a level of dissolved oxygen in milligrams per liter. So the first location gave a DO or dissolved oxygen of 4.53 reading. The second location gave them a 5.04, and so on and so forth. Okay. Okay. So for the 15, I found the average of the 15 was 4.771, standard deviation 0.9396. The population parameters, the true mean dissolved oxygen level. Doesn't say what stream or what specifically, so. Okay. Hypothesis, the claim is 5. That's what we're testing, right? But an average of below 5 puts it at risk. So if it's above 5, it's okay. There's no risk. But if it's below 5, that's when the risk occurs. So that's what we want to test. We want to test where the risk is. Okay? Significance level for this guy is 0.05. Okay. Let's see. Conditions. SRS. 10% condition is shape approximately normal. Okay. So it was stated as randomly chosen locations. So stated N is less than or equal to 10% of big N. Little n was 15. All locations for that, because there were 15 locations. Okay. Shape normal. We have our 3 options for means. Number 1, it was stated, given that the population is roughly normal. They didn't say anything about that. Number 2, they didn't say anything, but our sample size is big enough. No, our sample size isn't big enough, so we're going to have to do number 3 again. Number 3, so we're going to check for outliers and check for any skewness. Zoom set. So the picture I get was okay. No outliers. And it doesn't look like any skewness, but let me double check my histogram. Nope, it's pretty symmetrical, actually. The picture is pretty symmetrical. So no outliers and no strong skewness present. All right, test statistic. It's T. So T equals over, okay. Calculations. So the claim was 5. My sample mean was 4.771, so that's just below. And then my alternative was less than. All right, so that's where I'm going to shade less than, wherever the alternative says to shade. We only got to shade one side of this because it's only less than. Okay. So T 4.771 minus 5.9396. Okay. Oops. So my t-score is negative 0.9426. The p-value is 0.1809. So the conclusion is the last thing. So since the p-value 0.1809 is greater than alpha level 0.05, we fail to reject the null hypothesis. Therefore, we lack convincing evidence that the true mean dissolved oxygen level is less than 5. Okay. So we can't reject the claim that it's 5. We can't reject that claim. If we could reject the claim, then there'd be concern. Nope, it's not 5. But since we fail to reject, we have no concern. There is no concern. Okay. All right. Tomorrow, I'll give you your assignment. I'll let you guys work on it in class. That's all we're going to do tomorrow. is I'll have that ready for you guys to go. And then Thursday and Friday, we have one little thing left to do in the chapter, and then we're done. So next week, we'll start reviewing, have a group test next week, individual test next week, do all that stuff.